Welcome, and thank you for joining today's webinar on how to reduce inventory and improve customer service with SAP IBP. During our presentation, we'll go over the volatility of the supply chain and its effects on inventory and customer service, and how it can be improved by SAP IBP. Next slide. Today's speaker is Shailendra Kumar, the Senior SAP IBP Functional Consultant here at Krypt. Shailendra has been an integral part of successful implementations of SAP IBP projects worldwide and has worked extensively in process designs and configurations. On the next slide, I will go over some quick housekeeping tips. If questions come up during the webinar, please type them into the panel as shown in the example. We'll be addressing them at the end of the presentation. And if we run out of time and don't get to your question, we'll be sure to follow up with you after the webinar. On the next slide, I'd like to quickly introduce Krypt to those of you who are less familiar with us. Krypt was established in 2008 and is a leading SAP consulting partner. Although we operate globally, we consider ourselves a boutique consulting firm that lives by our founding principles of innovation, collaboration, and drive. These principles have allowed us to complete over 800,000 SAP consulting hours in various industries. Our service is focused around implementations, upgrades, and customizations for various SAP solutions, including trade, transportation, warehouse, planning, IBP, and HANA. We also offer proprietary solutions, integration services, and work closely with SAP for ramp-ups and testing. On the next slide, I'd like to go over some of our thought leadership. We strive to be thought leaders in the supply chain ecosystem, and we've accomplished this by offering books in addition to writing blogs and white papers, which are available on our website. Moving on to the next slide. This is an overview of our proprietary offerings, which complements the SAP suite. I wanted to briefly highlight Krypt Connect, located in the middle of the solution list. This particular solution can be integrated with non-SAP ERP systems, which many people find valuable. Moving on to the next slide. Over the years, we've had the opportunity to work with a variety of companies within the SAP supply chain space, and some of them are highlighted here. And with that, I'll pass it over to Shailendra.
Thanks, Rachel. So, good morning, everyone, and welcome for the webinar on inventory optimization, working capital versus the customer service level. So today's agenda would be supply chain planner's biggest challenge. What are the challenges? We'll look into these challenges in a brief, then followed by SAP IBP for inventory overview, followed by a live demo. We'll look into different scenarios and how to tackle some of the challenges that currently the industry faces. Then we'll also look into the safety stock drivers. If time permits, we'll also look into the lot size analysis, followed by analytics and dashboard. We'll see how to create some of the analytics and how this can help any industry to drive towards their goal, and followed by an SAP IBP advantage. So what problems are we solving today? Inventory optimization is a challenging topic. Companies need to keep enough stock to keep their customers happy, but as little as possible to keep cost low and to prevent the stock from becoming obsolete. Think about the amount of money you would want to keep in your bank account. You need to have enough on hand to cover for your monthly expenses. Even if something unforeseen happens and you need to do some unexpected purchases. But on the other hand, you wouldn't want to have too much money laying around, because elsewhere you would get a better interest rate. The advantage is your money doesn't have shelf life or will run out of season. So what makes inventory planning so hard to do? Exactly that trade-off. Companies want to meet the highest possible service level, but at the lowest inventory cost. And even for a single location, inventory target setting is not easy. There are a lot of influencing parameters. On the supply side, these are topics like how often do you replenish? Do you need to order in certain batch sizes? What is the lead time? On the demand side, the biggest topic is the forecast. Customer demand is volatile and barely predictable. However, even if you have all those numbers, the factor of variability comes on top. Does your supplier really deliver the whole amount ordered? at the expected time? Is your sales representative maybe constantly over forecasting? To cater for these uncertainties, company need safety stock. There are many ways and tools to calculate inventory targets, but many of them tend to oversimplify the situation. The problem here is oversimplify the situation. For example, they have a deterministic approach without taking the uncertainty and variability into account. Also, many tools calculate inventory targets stage by stage, which results in excessive over buffering, as the parameters that influence the calculation are varying over time. The output should be time varying as well, and not a fixed amount for several periods. Within a supply network, all those factors multiply, and more than often, supply chain tends to look like an image on the right, not like the one on the left. So with supply chain becoming global, what happens? It becomes more complex. The supply uncertainty increases. Like you can see the diagram, the demand variability also increases. And if the demand variability increases, what will happen? Your forecast error increases. So in order to cater all this and to balance this out, IBP for inventory optimization plays a very integral part. For a multi-stage network, the question where to place inventory is an important one. Not only the customer-facing DCs need safety stock, but maybe the production site as well. And for all the different locations, there is a huge amount of influencing factors that have an effect on the inventory targets. Let's have some more example right here, like SL targets, forecast error on the demand side, but also the fact if the demand is internal or external or both. On the supply side, we already mentioned lead times and batch sizes, but of course, there is more like capacity restrictions as well. Also, many companies populate their customer service level throughout the supply chain, but there may be internal SLs, internal service levels as well. So this is a supply chain, a simple model of a supply chain, which we'll be looking into for today's demo session. So what is the magic about a multi-stage optimization? Many tools only calculate inventory target for finished goods or calculate the target stage by stage, adding up buffers. IBP for inventory optimization, it optimizes the whole network simultaneously, recommending your safety stock targets for every node in the network, from raw material to semi-finished goods till the finished product in the customer-facing node. We'll be looking into some of the examples of this, how it optimizes the inventory levels at different nodes and for different components. This is a simple architecture of an IBP. I thought I want to put this in this particular demo just to make sure that how the architecture on IBP looks like and where an IO can play a part, inventory optimization can play a part. In the left-hand side, you have a different ERP solutions. So you can connect an IBP through an HCI. Formerly, it was called an HANA Cloud Integration, but now it is called a CPI Cloud Platform Integration. So through a CPI, you can connect any ERP system, or if it's a flat file or any third-party system or a legacy system, to an IBP. In an IBP, you can carry out various scenarios, simulations, analysis, alerts, heuristics, optimization. So if you bring these data, like for example, the master data and the transactional data into your IBP, you can carry out an optimization, and very well you can send out some of the results back to your SAP ECC or an S4 to carry out the execution. You can have this thing in an Excel-based plan. It is provided with a web analyze where you can look into the data dashboards and take some of the key decisions. You can very well carry out this in a PDA also. In the lower half, you will find the social collaboration that helps in collaborating. Suppose there's a safety stock level that at a particular node which you are worried about, you can just share it with different stakeholders or to the people or to the person who is concerned or who is on that area, who takes care, who manages that particular area. So you can just share it with these and you can take very well decision beforehand. So it actually reduces the lead time of taking a decision. So in the right hand side, it's nothing but different stakeholders of a supply chain, like for example, a sales, marketing, demand planning, finance, supply chain executives. So they all come under a roof and can take a decision. So it becomes a more collaborative planning instead of an siloed planning. So what are the key drivers of an inventory? Before jumping into the IBP live demo for inventory optimization, there are a few points that we need to see. For a cycle stock, it is the batch size, it is the demand, it is the period between review. If a period between review goes up, your cycle stock will also go up. For a pipeline stock, if your lead time goes up, your pipeline stock will also be affected in the same manner. It's directly proportional to. But what about safety stock, which every industry is concerned about? How much they should recommend a safety stock at a particular node. So a key drivers are forecast error, the supply uncertainty, the demand variability. With demand variability, there comes a forecast error. And with supply uncertainty, there comes at different levels of a recommended safety stock at a customer-facing DC or at an internal nodes, like for example, a warehouse or a plant, how much you have to recommend a safety stock there. So some of the factors, like if you increase the PBR, your safety stock will get affected in the same manner. If you increase the lead time, your safety stock will get affected in the same manner. For today's demo, we'll be looking into some of the factors, like for example, how a forecast error influences your safety stock, how a production lead time influences your safety stock levels, and also one more, that is the target service level. If you change the target service level, how your safety stock changes. So let's go into the demo. If they are new to IBP, this is how the web URL looks like. It has got some of the Fiori apps here. You can carry out configuration and different various tasks with this Fiori app. Here in this particular inventory planner app, here we actually defined how to calculate a forecast error. So for a forecast error, it takes up some of the measures. Like for example, it takes in the demand, it takes in the sales. You have a sales for actuals history for the past period. You have a demand calculated for the past period. So it will take that into measure and it will calculate the forecast error coefficient of variation. So you can select some of the ways, like for example, I have selected a mean absolute deviation. You can select a MAPE also. And you can see that you can adjust a particular forecast with the bias also if the sales representative is constantly over forecasting or under forecasting, then you can have a bias, a positive bias or negative bias. You can very well take that also into account for your calculation of a forecast error. And with the use of that forecast error, you can run a multi-echelon multi-echelon inventory optimization. And with that, you will get an output like a recommended safety stock. Okay, so let's jump into the system. So this is where you can download a template. So if you have uploaded a template here in a different folders or as a worksheet, you can download it from here. So I have downloaded a pre-built template. So that's for the today's session. So this is a demand input wherein we have a demand forecast, we have a demand forecast error CV, we have a target service level. Similarly for production input, we have like production lead time error CV. Let me just increase this up with a decimal point. Yeah. With a transport, we have a transport lead time. You have a transport error CV, minimum lot size, incremental lot size. We have got some inventory views over here. So that will give like what is the recommended safety stock, cycle stock, what is the target, a high level result at a product family level. If you want to have, like, for example, at a upper level, they want to see a high level result, you can have it for a product family level at a DC location, how it looks like, the recommended safety stock, how it looks like, what are the values or in the terms of cost. A detailed result at a product level, you can have it at an individual DC. So you can just configure this, or you can map it based on as per the requirement of an industry. It becomes a very flexible tool. It acts like a very flexible tool, and it can be modified anytime over a fly. So these are some of the drivers of a safety stock, and we'll see like if the recommended safety stock changes, how a demand variability comes into play, or how a service variability comes into a play, or how a supply variability comes into play. So let's go back into a demand input, and we'll add a scenario over here. You can create a scenario from here, this particular tab here. You can create a scenario. So I have created 3 different scenarios for today's demo session. One is the forecast error CV increase, the other one is the lead time increase, the other one is the target service level increase. First, we will work out with the forecast error CV. You can also share this scenario if you want with other group members. So suppose in an inventory planner, there are 4 to 5 people, and one of them has already carried out inventory planning and recommended few safety stock at a different scenarios. They can very well share it with a concerned person. You can promote it also if you like the recommended safety stock for a particular scenario, and then you want to promote it to a baseline level. You can very well do that also. Okay, so let's go into the edit view and add a scenario. So our first scenario would be a forecast CV increase. I've added a forecast CV increase scenario here. I'll just change the layout. Okay. And similarly, I will do it for the inventory view as well. I'll just add a scenario over here. Okay. Now we are good to go. So as you can see over here, the demand forecast error CV, I have kept it same. Okay, for a baseline and for another scenario. Now for this particular scenario, I will just change the error. I will increase the error by a few decimal points. Okay, so at a retail level, I have just increased it. So let's do this for at a wholesale level also. Okay, I'll simulate it. You can very well simulate this thing and get the results. If you do not save it, it will not save. So a simulation result can be saved also. So let's go and simulate it. I'll simulate the multi-echelon inventory optimization. Okay, so it's running. It's executing a report. And based on the simulation, it will populate like how much of an safety stock is recommended at this particular location. So let's go and see into an inventory view. Look, the safety stock has changed by from 439 to 1099. The safety stock value has increased. So this is how a simulation can work, and you can take like various scenarios to work on. Now the simulation that has worked, it's all not only for a DC location. So since we are doing it only for a DC facing the customer, so it will, so that's why it has populated a safety stock at this particular level. Now let's go back to a demand input. Let's change this to 0.25, and we'll save this, and we'll see how it affects, how you can see the data in the analytics view as well. Let's save this. You can save it via a save icon over here. Once the data is saved, you can run a multi-echelon. So here you have a multi-stage inventory optimization. Now we have done this change for this particular scenario, forecast CV increase. So I'll select both of the scenario here. For my planning unit is web NT, and then a next run. Okay. You can check a status of your in planning operator. So if whatever job you have run, whatever job you have scheduled, you can very well go over here and check the status. So it is scheduled. You can refresh it from here. It will take some amount of time for it to run, and then it will populate the result. Okay. So meanwhile, it is taking time to populate a result. So, oh, okay, so it's finished. Now, from here, if you click this thing, it will give you an error report or a job report, basically, not an error report, but a job report. It will show that how the job was run and what all things you have selected and or other information. You can also see this log report from an app that is there in the web URL. Now let's go and look into the inventory views. Look, the safety stock level has changed because we have reduced it to 0.25, and how it has affected the inventory view over here. Now, if you want to look, we can also show you in the app. Let's go into a dashboard and let's see how the safety stock level has changed. Let's go to this particular app, particular analytic view. We'll just refresh it. Now look, with a base, sorry, this is a lead time. Okay, let's change the scenario. So scenario is forecast CV increase and a base version. We can compare. Now you can see it will give you a picture in a percentage view. So basically this will help you in taking like a percentage is always helpful in taking decisions, right? So 32.15% it shows in a base version where you have a CV of 0.1, and when you have a CV of 0.25, it shows like 67.85. So that's how you can see in the dashboards as well. We'll go back in the dashboard. We'll revert the changes over here. Okay, now save the data. Now we will go and look into the another scenario. The another scenario is how a production lead time gets affected. So let's go, let's go into an edit view, and we'll unselect the forecast CV increase and we'll select the lead time increase scenario. Now we'll go into a production input. The layout will just add it over here. In an inventory view, it's already added. Okay, our drivers, will just add it into the drivers as well. Now you can see I've just added a particular scenario into a production input. Okay, so here we have to select this scenario as well, and yeah, we are done. So as you can see in a production input, there is a lead time increase and a baseline scenario. Okay, let's increase them. Sorry. Okay. Now in a baseline, it's a 0.1 as a service error and a production lead time as a this, but we are not going to change the error over here. We are going to change the production lead time here. So let's say a baseline, at a baseline, you have a production lead time of 1, and in a lead time increase, we do it till 3. You can very well carry out a simulation, but here we will save the data and see the effects in dashboards as well. Let's save this. Now we are going to run again a multi-stage inventory optimization. We'll select the scenario, baseline, and a lead time. We'll select the planning unit. Yes, we are good to go. Similarly, we can check the status. There is one more schedule. So if you schedule a job, suppose a particular day of a week, you have scheduled a job, you can very well see this particular option. So let's go and select the status and see how the status looks like. So now initially a job will be scheduled and then in process and then it will be finished. So either it will fail or finish. If it fails, it will pop, it will show over here it is failed, and then you can download a log in order to see why your job has failed. If there is anything that you can do it and look into the, it can be because of a data, it can be because of incorrect settings at your operator level, it can be anything. So it will just populate some of the messages, and with this message, with that message, you will have to decode it and get into the root level of the root cause of the particular operator. So it's finished. We'll just refresh it. Okay, let's go into inventory view, how it looks like in an inventory view. Okay, now we have changed the production lead time. So look at here, the DC level, it shows the same. But if you go down to a warehouse level, it will show you the difference. Look at the difference here. Now look at the plant level. So that's why it is so interesting. The IBP inventory optimization, it actually runs at every stage simultaneously instead of running stage by stage, which adds up a buffer. So if it would have been running like a stage by stage, it would have just given like a particular buffer, increased buffer at a DC, which is facing the customer, because the production line from which it is getting sourced, it would have just increased it because of the change in the production lead time. But here, it hasn't done that. So here, if you see, it has just changed the safety stock level. It is recommending a higher safety stock because of the change in the production lead time, as well as in the warehouse. If you see, it has changed with a few parameter, few number. And now in both of the warehouse, it has changed. Why? Let's look into the view. Now, this is a particular supply chain that we are working right now. Okay, so you can see in this plant, the finished good is being produced and it has been shipped out in the warehouse, and warehouse is shipping out to all the DCs. So this particular production plant is shipping to both of the warehouse. That's why it is changing the level at both of the warehouse. So that's how you can just analyze it. You can see the results. Let's go back to the view. Let's also look into the safety stock drivers. With the change of the production lead time, let's see how the variability has changed. Now, in a particular plant, you can see the recommended safety stock has already changed. How it has affected the different drivers of a safety stock. A demand variability. Look, the demand variability, there is the highest because of the demand variability, and there is supply variability a lot. Why? The most is because of the supply variability. This is because of the change in the lead time. So the supply variability, it is causing a lot to the safety stock, and with the demand variability, it is causing at the second, and then the service variability. So this is how you can take decisions. These parameters actually help any industry or any planner to take certain decisions, how the drivers are affecting it. And if it is because of supply variability, then they can look into the supply chain in the right hand side of the supply variability, like what are the parameters of a supply variability that is causing it a change. Let's go into the dashboard and see some of the, sorry, okay. Let's look into the safety stock level. Okay, we'll select the scenario from here. So we have done this for lead time, okay? And we can select the different locations from here. So we have done this for warehouse. So let's look into the warehouse 1 and warehouse 2. So let's only look into the warehouse 1. Okay, warehouse 2 and a plant 1 as well. Okay, so you can see 49.88 is because of the base version and 50.12 is because of the lead time increase. So this is how your safety stock level differs. So let's go back now and run a third scenario, which is for our service level. Okay, first let us change this and make it the original value. Save this. Go back to demand input. Let's add a scenario and remove one of the scenario from here. So lead time scenario, we will unselect it. Service level scenario, will add it. Okay. To an inventory view again, scenario is added. Drivers, yes, added. Okay, great. We are good to go. Okay, and yes. So let this planning report gets refreshed. Okay, now you can see that I have given a service level of 0.95% both at a baseline and at this. So let's change it. Let's make it 90% at a retail level as well as at a wholesale level. So though I've given a name of a TSL INC, but we are reducing it. So let's save this data. Now let's run the inventory optimization multi-stage again by selecting the different scenarios. Okay, all good. Next. Yes. Let's look into the status. Okay, it's in process. It will take a minute to complete. Okay, it's done. Let's go and look into the inventory view, how it looks like at a particular DC location. Yes, you can see at a DC 11001. So if a service level is highest, you need to have a more amount of safety stock at that particular node. So if you remember, let's look into this also. So in a baseline, we have 95% of a service level. In a TSL ANC scenario, we have a 90% of a service level. So because the service level has reduced, we have a less amount of safety stock to be stocked at that particular node. Okay, and at the baseline we have a 439. So this so how a service level impacts or influences a recommended safety stock, how forecast error influences it, how we have already seen the production lead time. You can also do a transportation lead time changes. You can add a scenario to a transportation lead time. You can change it and you can see the impact in a safety stock. Let's also look into the drivers, how it has affected. Okay, now look at the safety stock. Since the safety stock has come down, the demand variability, because of demand variability, it is being affected the highest at a DC level, and with the supply it is the second. And let me increase this thing. Okay, and with the service level it is at the least. So this is how you can compare the scenarios. We can also look into their dashboards as well. the safety stock level for TSL increase. Yeah, okay. Look, we can just change it and refresh it, and you can view it in the dashboards as well. So this is how you can take these into account. Let us unselect some of them and look into some other reports that is generated once you run the inventory optimization. Let's remove these scenarios from here. Do I need to? No. Okay, we are good. Layout, yes. Okay. So once you have executed an inventory optimization, it will not only gives you a value for finished good, it also provides a value for components like raw materials, like semi-finished goods as well. First, we will look into the high-level result, a high-level result of a product at a product family level. So if we look at a product family at a particular DC, how it looks like, your recommended safety stock, how much of a safety stock is required against a propagated demand, then what is the value, how much of a delta is there. So if there is any alerts, you can also provide an alerts to it, and you can have a view to this. If you want to look into a more detailed value, not at a product family, but at an SKU level at a particular DC, you can also have this. So similarly, if we have run a scenario for this current week, you can also run a scenario for the coming weeks as well. So here, if you see a particular product at a location level, so how it looks like, your safety stock, if there is any adjusted safety stock, you can very well give this here. This is an editable key figure. Then your any delta percentages. So a lot of things at a detailed view. Here, if you see, it is giving as a yellow. So this is a formatting that I have done. This is a formatting that I have done to a local member key figure. This is a local member key figure that I have created only for this particular planning view. You will not be able to see this particular key figure in the configuration app. This is because I've created this for as a local member, and I have formatted this so that if there is any change, like for example, I have given different thresholds level. If it is more than a particular percentage, it will change into red. If it is less than a particular percentage and more than a particular percentage, it will turn it to green, yellow, so like this way, to give it a more appealing look. Let's go back and look into the more detailed view of the output of an inventory optimization. So suppose let's go into this and select our products. Now I don't want to see my finished good, but I want to see my semi-finished goods and raw material. How does it looks like, right? So I can just select the filter. Okay. It's taking time to refresh it. Okay, we are good. Now you can see at a raw material level, what is a recommended safety stock. At a semi-finished good, what is a recommended safety stock at a particular plant level. You can also, if you have configured at a supplier level, you can also see at a supplier level how much it is required. So similarly, you can also, if you want to look into a projected stock, you can very well see that. So you will have to pass this input to supply planning, run optimization or a heuristic, and the system will populate a projected stock, and then you can see what is your on-hand stock target versus your projected stock. How does it look like? Okay, let's go back to the dashboards now. So in a particular dashboard, we have seen one or two analytic view. Now we'll see some more of them, and we'll see how it can help you to take some of the decisions. Like for example, this one. We'll go into the detailed view of this particular supply chain. Okay, now you can see this is a particular supply chain, right? Where I'm showing the live demo on. So these are the values. These are the values of your recommended safety stock. How it looks like. It gives you a pictorial view. Over here, the recommended safety stock value is the highest than compared to other 2DC location. Then here at the two warehouse, it is more or less similar. And in the plant, it is at the medium level. You can very well find out at what range it lies with this particular view. Now you can change it to a cycle stock. Suppose you want to see a cycle stock, how does it looks like? So you can go and refresh it. Look, your cycle stock, how it looks at different level. Sorry. Why is it not populating? Okay. I think so. I'm experiencing some kind of issue with this. Anyways, you can just select a particular key figures over here. So the number, okay, it is changing. So you don't have to refresh it. Look, it is changing. If you look into this particular thing, if I select this, it is changing, right? So if you configure the key figures in your analytics app, you can very well change those key figures and see how the values are changing. So for a particular cycle stock, pipeline cycle stock at this particular 2DC, it is at the highest and then it is lowest over here. But for a recommended safety stock, it is same in this 2DC, but it is different for here. Like for your cycle stock, this is at the highest and this two are the lowest. So this is how you can look into the analytics view and take some key decisions. You can also create some of more analytics. Okay, so like for example a heat map, or for example this particular app. Let's go into this inventory view at a global. So your supply chain. So your supply chain is a global. Now what I have done is I have given some of the coordinates for DC and the warehouses. So it looks like it's all scattered in the map. Then this bubble, it actually gives you like what is your target inventory position. The higher the target inventory position, the larger the size of the bubble. So this is how your analytics view would look like in a global. You can create some of the very informative analytics view. So some more like what is your days of supply in terms of a recommended safety stock or on-hand stock. Those things also you can create, like on-hand versus inventory position, then a recommended stock, how it looks like in the terms of value, right? And then how much is the lost customer demand over the period of time. So inventory accuracy, if you want to configure any of the KPI, it would look like this. And then you, of course, we have seen this as safety stock level. So let's get back to our presentation. So what we have seen so far. Now, what we have seen so far, we can very well discuss about the IBP advantage. Inventory reduction, the very first point. Multi-stage inventory optimization, use less inventory to buffer more risk. We have seen that. Visibility and transparency. Yes, the embedded analytics helps you and giving a visibility across your supply chain. We have seen that the recommended safety stock levels or the target inventory positions. And what if analysis, we have run some of the scenarios to see how it can influence the safety stock or a cycle stock or a pipeline stock, and how drivers of a safety stock is how it influences the safety stock. So efficiently master supply uncertainties. We have seen how a supply uncertainty can influence your safety stock, and then buffer forecast error and demand risk. So we have seen like how to when we have changed the forecast error, when we have covered the demand risk, how it is going to affect your supply chain. What are the key differentiators for? So let's summarize what are the key differentiator for IBP inventory here. It is an it is integrated into the IBP platform. So inventory planning becomes a seamless part of your sales and operations planning as well. So suppose in a sales and operations planning, you have a demand review, supply review, a pre-management review, and a management review, and you want to incorporate inventory optimization results into your sales and operations planning. What you can do is you can run a demand review, a demand planning cycle, and then you can run an inventory optimization. And from that, you can have a recommended safety stock as an input for your supply planning. And then you can run a heuristics and or optimizer to get your constrained demand plan. And with that constrained demand plan, you can send it back to your ECC or S4 to run your operations level or your execution at an operational level. Multi-stage inventory optimization. We have seen the advantages of MEIO, multi-echelon inventory optimization, how it is different from some of the other tools available in the market. It doesn't run stage by stage, but instead it takes all of the stages simultaneously at the same time. Real-time scenario planning that allows for strategic supply chain management. So once you have calculated the inventory targets, the scenario functionality lets you examine your supply chain. We have seen that, and let you evaluate things like the effect of lead time, your forecast error, your stock targets, and other things. Simplified experience, unified empowerment. We have just seen like how a real-time insight can help you monitor aggregated or detailed level of a safety stock. Then we have seen some of the flexible data models, integrated business planning processes and the value chain, real-time planning, simulation capabilities. Then we have also seen the social collaboration platform, that the analytics view that we have embedded in it, and role-based user experience. So if you have a role-based user experience, it becomes a very handy. You can define a role, and then you can give it a role to a particular planner, and you can very well assign this thing to a particular role or a group. That's how it works. So integrated business planning for inventory. Achieve the right balance between inventory and service level with multi-stage optimization. Fix the mix of inventory by item and location. Use inventory more efficiently to buffer risk and uncertainty at least total cost. What are the business effects? So over the years of implementation by the inventory, what SAP has provided as a detail, like improve customer service levels by 5 to 10%. They have seen that some of the clients have reported a 5 to 10% improve in the customer service level. The working capital has reduced by 15 to 30%, which has affected the obsolescence and the inventory carrying cost in a positive way. Improve your planner productivity with 20 to 40% less time spending. So if you see here, we have seen like how a lead time of a planning reduces with the flexibility that SAP IBP for inventory optimization, or in fact an IBP provides to a planner. So this gives you a more efficient or more effective supply planning. That's all for today's webinar on working capital and customer service level. Hope you all have enjoyed this webinar and got some of the insights. If you have any questions, please write back to us. Over to you, Rachel. Thank you, everyone. If we have questions, I can take those questions.
Thank you, Shailendra. It looks like we do have a couple minutes to answer some questions that have come in. The first question is, if I want to integrate my inventory planning results with supply planning, how do I do that?
So in that case, once you have run an inventory optimization with the help of the demand and the supply key figures value from your demand planning, you will have your forecast error. When you have a forecast error, you provide them as an input, and then you have to run an inventory optimization. You will have a recommended safety stock. So what we have seen is we provide this recommended safety stock as an input for your supply planning. So once you have this as an input for your supply planning, you can just run this. You can either do a copy kind of thing, or you can make this as an input directly if it as a same level in the supply planning as well as in the inventory optimization. There are various ways. It depends entirely upon the requirement of a business. It changes business to business. Then it becomes an input for your supply planning, the recommended safety stock, and when you run a supply optimizer, you can have a constrained demand plan, constraint plan, basically, which forms an input for your production planning or MRP run, which will result in a planned order or a purchase requisition and all those. Yeah, so next question.
Okay, next question is, if I want to see the impact of independent demand in any of my locations, how do we do that?
Okay, so let's go back into the system for this thing. So suppose a particular DC location, let's go into this particular. Yeah, suppose in a particular DC location, in this particular location, there is a constant independent plan over here, constant independent demand over here. And I would like to see the impact of this particular DC location for that independent demand. And I do not want to change the result for any of the other locations. And how do we do that? So for that, what we can do is, once we have run the multi-echelon, we will have to run a target inventory components, this particular calculate target inventory components. Now, after running this calculate target inventory components, it will calculate all the SFGs or raw materials required. And then after that, we can run a decomposed single stage inventory optimization. Here we can give a filter. So with that, we can provide a filter, like for example, in our case, in our scenario, we can just give a location ID here and a product ID here. We can choose a location. So suppose for this particular location and this particular product, and if I run this, if I click this next, it will execute a decomposed single stage inventory optimization. It will, however, it will not affect the other safety stock levels or other planning results in the other locations. It will only affect on that particular location. Yeah, any other question we have?
Oh, looks like we have one last question. Can we see drivers of safety stock in percentages rather than in absolute values?
Yeah, so okay, so I'll just forget to show one of the analytic view. So here, if you see a particular recommended safety stock, we can see an absolute value, but some of the clients wants to see these value in a percentage format because it gives a better view, in a better view. So how you can do that? So for that, you can just have a dashboard, or you can create a local member if you don't want to create a key figure. So if you want to create a local member, you can create it here. If you do not want to create a local member, but you want to create a key figure, you can just create a key figure and add an calculation like sum of all these, this divided by sum of all these, and then you will get a percentage of a demand variability. But if you do not want to do any of these, then what you can do, you can just have a display over here in a particular analytic view. So here you can see that since the service variability is too less, that's why you are not able to see over here in between is the service variability. But you can see that this is divided into the percentages, and it forms like 84 forms the 19.03%, and 355 forms the 80.96% of the total view. So you can very well create this and get your decisions. So this is one way, and so I've given like 3 different ways. So these are the 3 different ways. Whereas you can have, suppose if there is any other requirement, any other specific requirement related to this, you can very well model it. So IBP is like a very flexible tool. You can model it in a go based on the requirements. Yeah, so yeah, I'm done. Are there any other questions?
That's all the questions we have for today. So thank you, Shailendra, and thank you everyone for joining the webinar. We'll be sending out the slides in the next few days, so keep an eye out for those. Thanks again, and we'll see you all next time.
Thanks everyone for joining this webinar. If you have any doubt or any question, please write back to us. Thank you.